Hey everyone, in this video we're going to examine some common units for gas pressure and talk about how to convert back and forth between them. Remember from the last video that gas pressure is caused by particles colliding with a surface, and as they do so, they exert a force against that surface. So the pressure inside this container is caused by the particles colliding with its inside walls. And if there was an object inside this container, then the particles would be colliding with the surface of that object too and exerting a pressure on it. So let's start off by talking about a very specific type of pressure known as atmospheric pressure. Now this is gas pressure, exactly the same as we just reviewed, except it's very specifically the gas pressure within Earth's atmosphere caused by collisions of the molecules that make up air. So in the atmosphere, we have something unique happen caused by the gravitational pull of Earth. Earth's gravity pulls the particles downward, so there's actually more particles closer to sea level and less particles at higher elevations, and you can see that represented in the model. The result of this is that if you are at sea level, because there's lots more air particles around you, you're experiencing lots more collisions on your surface or any object at sea level, which means at sea level is going to be a higher pressure. As you go up, maybe up into the mountains at higher elevations or on an airplane, because there's less air molecules, there's less collisions and even lower pressure. And if you take this to the extreme, eventually you hit outer space where there's no air whatsoever, so there's no collisions, therefore there would be no gas pressure. So let's use this idea of atmospheric pressure to introduce some of the common pressure units that you'll come across. Now, for atmospheric pressure, that's typically measured with a device called a barometer. Barometers use something known as millimeters of mercury, or mmHg, to measure pressure. The model we've been looking at uses something called kilopascals, or kPa. The average pressure at sea level is defined as 1 atmosphere, or ATMs, and maybe the most common one, pounds per square inch, or PSI. This is what you use to fill up a bike or car tire. And of course, there's many more that we're not mentioning here. These are just some of the most common ones. The last thing we need is what I'll call an equivalency chart that shows all of these different pressure units laid out equal to each other. So 1 atmosphere at sea level is the same thing as 14.7 psi, is the same thing as 760 millimeters of mercury, and so on. We can use these equivalencies to convert between one pressure unit and another with our old friend dimensional analysis. Let's take a look at one example of exactly how this process works. So this question says that the atmospheric pressure at cruising altitude for commercial airplanes is about 30 kPa, and then it asks for that same pressure in atmospheres, or ATM. So remember, with dimensional analysis, the first thing I'm going to do is write down the number that I was provided and whatever unit that number has. In this case, we're told that the pressure at cruising altitude is 30 kPa. The next thing I'll do is set up my conversion factor that will change kPa's into whatever other pressure unit I want. Remember that the units have to cancel from the top to the bottom. So I've got kPa here that's going to cancel off with the kPa that I put in the bottom of my conversion factor. Now the nice thing about pressure conversions is that because I have all of these units laid out equal to each other, I can convert all of these in just one single step and change kPa straight into any other pressure that the question wants. In this case, atmospheres. Since they're all equal to each other, 1 atmosphere is equal to 101.3 kPa. So I can change from kPa's into atmospheres. That'll be on the top of my conversion factor, and just put the numbers in the appropriate spots. 1 atmosphere is equal to 101.3 kPa on the bottom. Now we do the math, which is simply 30 times 1, which is just 30, divide by 101.3 to give me an answer of 0.30, rounded off properly. Now this 0.30 is the pressure in atmospheres, and we've answered the question. These pressure equivalencies will also be our main key idea for this video, so make sure you pause and take a minute to write them down. That concludes this video on pressure conversions. Here's a brief summary.